All right, thanks for coming. I continue this theme of speaking about community culture, but I look at it from a different perspective. We look at the culture of communities in terms of norms and values that are established in communities, and how different communities have usually fairly cohesive values and fairly cohesive practices, but among different communities you see huge differences. And I want to talk about some of those effects and what you can learn from looking into other communities. This is joint work with Chris, Anna, Jim, and Ferdian, and I'm Christian Kästner. I'm teaching at Carnegie Mellon University, so this is not a talk based on experience, but actually I don't have that much experience with JavaScript, to be honest. This is from an outsider's perspective. So we study ecosystems kind of as an outsider, and we hope that by doing this, we kind of have an idea of a better perspective of comparing different ecosystems, learning about this from the outside. And we've been looking into this as a research projects, which we called Breaking APIs, for the last couple of years. And we have a Twitter account and a web page based on this that I'm going to advertise more a little bit later. So we look broadly at software ecosystems, and with software ecosystems we mean communities that form around packages, that form around platforms, sometimes products, where you kind of have a network structure of dependencies. So you can depend on a package, and that package can depend on other packages, and you have many of those communities around in different languages, in different products. And the main message of this talk is actually that the culture of the ecosystem matters. There are lots of different values. Different ecosystems often adopt different values. Different things are more important than other things, so they make different decisions. This leads to different trade-offs. So you can't achieve everything perfectly. So some communities favor some things over others. And following this, you see different cost allocations. So some people have an easier time, for example, people new to an ecosystem, or people established, or people that put money into an ecosystem. And you often see consequences in terms of what we call ecosystem health. So are there specific problems that you see in an ecosystem, like it's hard to retain developers in this ecosystem, or a lot of packages are generally considered low quality, things like that. And why would you want to learn about this? There are lots of different issues where this might actually be interesting. Let's say you want to change a policy or introduce a new policy. Let's say you want to change the default versioning rules in your ecosystem, or the way how you upload packages, that packages need to be reviewed first in some way. So how do you make this decision? How do you think about those trade-offs? How do you decide whether this is a good idea? What are the consequences based on this? So understanding the space, understanding trade-offs can really help. Or you want to fight a health issue. Let's say you have a problem retaining developers, recruiting new developers. What can you do to, what design decision in your ecosystem might be contributing to this? How can you maybe debug your community to figure out what you can change? Or you might want to design a new community. I don't think many of us will design the next NPM, but there might be a chance that we are focusing on some sub-communities, say Hoodie, or some number of packages where you want to push specific values. What can you do kind of to foster goals in one community? And again, for this, culture really matters. It's important to understand the values, it's important to understand the trade-offs, and we've been doing research on this for a while. What I'm going to talk about is mostly based on interviews and surveys that we have conducted throughout the last couple of years. And we looked at this through one specific lens, and that's breaking changes. The idea here is that if you use a package, there are lots of dependencies often behind that package, and you depend on a number of packages. And all those packages have maintainers, and they could make just changes to their packages. And some of those changes are modular, so you just update and you have a great new version and everything works fine. But some of those changes are breaking changes. So they may change some of their APIs. So when you update, your code isn't working anymore, and you have to invest some time, you get interrupted, you need to invest some effort to update your code now when you want to migrate. And this can ripple through the ecosystem, so it can have consequences. A single change can impact hundreds of developers out there in their packages. So you can start thinking about costs. what's the cost of a breaking change in this sense? And we think about this as kind of a balance of who takes costs. It's somewhat an abstract concept, but in the extreme case, it's really easy to make a change and impact hundreds or thousands of developers out there who all get interrupted and who all need to invest in doing some rework. So it makes it really easy for maintainers to break something and puts the cost all on the users. But that's just one extreme. The opposite extreme would be you refrain from making a change even though it's really important to you, right? So there are lots of reasons for breaking changes. Nothing is really ever stable, but if you are not allowed to make breaking changes, if you really refrain from this, you're taking on costs, mostly technical debt, opportunity costs. Maybe you have some performance problems that you could fix with an API change, but you can't really do that. Right? So it can be really costly for you and maybe in the long term also for your users not to break anything. And then there's a lot of passes in the middle where you kind of, as a maintainer, you break something, but you try to reduce the cost for your users by mitigating some of those changes. A typical example is you invest some additional effort in writing a migration guide to make it easier for your users to update. You might synchronize releases with other packages or on a schedule to make it easier to plan changes, to not get interrupted in an inconvenient time. And practices like backporting and deprecation are mechanisms how you can delay the impact of changes, so it's not as immediate. And there are hundreds of those practices. And again, what I want to show is that different communities have different cost allocations, use different practices, and kind of really negotiate differently in this space. So in this talk, I'm primarily going to talk about 3 ecosystems. There are many more. Our webpage contains survey data on 18 ecosystems in total. But I want to dive in a little bit deeper on 3 of those. And I'm going to start with Eclipse and R, assuming that you know less about them than Node.js. Right? So while I'm talking about those ecosystems, think about what you know in your community, what practices you do, and how this is different from what you see in those ecosystems. And then think about why. Is this a good idea? Should this be different? Should we copy things that I'm going to show you from Eclipse or that I'm going to show you from R? So let's start with Eclipse. Eclipse is an IDE that probably most of you have heard of. Originally for Java programming, has hundreds of plugins. These plugins can depend on other plugins, so you have this ecosystem structure. And if you look into this community, if you talk to people, or even if you just look at their webpage, you very quickly realize what values are important in this community. So one important value is backward compatibility. They say on their webpage extremely explicitly, as the API prime directive, when evolving the component API from release to release, do not break existing clients. Right? They really focus on stability, and that's not something that they just say. This is culture that they live. And here I can show you some data from our survey, and I'm going to show you more plots like this. But how to read this is mostly, so we ask how important is stability to your community, and the higher up values are, the more important it is. These are all positive values, so we ask pretty much from a little bit important to very important. And most people say, yeah, stability is important, but what you still see are differences among ecosystems, and we have sorted this by average rank. And what you see is that Eclipse is really on the far end here. Eclipse is the ecosystem where on average developers rate stability as the most important practice, way more than other ecosystems. And this is consistent, largely consistent within this community. So this value that's communicated is actually accepted by the community, and you see consequences. So when we ask them, for example, about how often are you making breaking changes, or how often are you faced by breaking changes, you see answers that Eclipse is on the low end, actually, right? Fewer breaking changes than in other ecosystems, so this is actually a lived practice. In terms of cost distribution, what I've shown you in the beginning, this is pretty much on the extreme side where, as a developer, you're almost not allowed to make breaking changes. So people use a lot of workarounds, invest a lot of creative hacking in getting around these limitations. And there's also additional effort to further reduce the impact of changes by doing yearly releases. So there's a fixed schedule. Once a year, there's a major release. And then for those releases, large parts of the community synchronize and go through a month-long process of actually testing compatibility and checking things and so on. So everything is a trade-off. What can they achieve and what are the problems here? So Eclipse is an extremely stable platform. It's convenient to use. You can still install plugins that have been written 13 years ago in a new version of Eclipse, and they most likely still work. Try doing this with some JavaScript packages. Yearly updates are sufficient for many people in this community. You don't really need to update from week to week to see the next update. But this has consequences. Eclipse these days is perceived by many that we spoke to as somewhat stagnant and a stale platform. They have APIs that predate Java 5, so without generics, they couldn't really update some of those. And if I take my students as references, I would say the cool kids are not using Eclipse these days anymore. So at least in Java development, people have switched to IntelliJ largely. At least in my classroom, that's what I see. I'm not sure how much this is a representative sample, but by that same metric, also Twitter is pretty much dead. I'm not sure, the students these days. Eclipse reports that they have difficulty recruiting and retaining developers, and that also these coordinated releases are kind of a pain point for them, for the community. So they invest a lot of effort, but it's also painful. When we ask questions about health, so how much do you face the difficulty of recruiting new developers? It's on the far end. If we ask about how much do you feel limited in innovating in your ecosystem, it's pretty much on the far end. But on the other side, if you ask, are packages unstable? Not so much an issue. Right? So what I've shown you here is really one end. Eclipse has made specific decisions, which I guess you see as very different from your community. And they have accepted certain trade-offs and have certain goals with this. I want to talk about the second ecosystem, R, or CRAN is a package manager behind this, kind of the NPM for R. R is a language for statistical computation, and there are a couple of thousand packages on CRAN that are usually cutting-edge research in statistics. So when you interview people in this community, you often speak to physicists or to soil analysis people, researchers. We spoke to retired professors who still maintain some packages in this community. And they do something pretty interesting about dependencies and about versioning. We call it the snapshot consistency, where the goal is that the most recent version of all packages on the ecosystem should be compatible. So it doesn't matter that the newest version of package A is compatible with an older version of package B. It just has to be compatible with the newest version of package B at this time, right? So at any point, you should be able to install any packages in that ecosystem, update all at once, and it should be compatible. So to achieve this, this requires coordination. So what typically happens here is you're allowed to break things, but when you break something, you reach out to people in that community that are affected, you coordinate, and then you typically more or less publish both packages, your package and the affected package, at the same time. So there's kind of a sliding window, so typically 3 or 4 weeks until you have to do this. But as a maintainer, you have to react. There's a threat that you can get thrown out of CRAN. Your package can be taken over or get thrown out if you don't react, if somebody else that you depend on makes a breaking change and you can't coordinate with them. To make all of this work, there's a strong culture of gatekeeping and tooling to enforce this. So they run, some volunteers review changes, so you don't just upload things as an NPM, but you actually submit your changes, somebody reviews this, they run tests on the entire ecosystem to see whether something breaks. In terms of costs, we have a different picture. So you can make breaking changes, but you have to reach out, and some volunteers take on some of the additional costs, and you kind of have this constant synchronization here. In terms of values, it's not quite that obvious as in Eclipse. It's not strongly communicated on their web page. When we talk to people that are kind of core members of this community, they say they want to make it easy for end users to install and update packages. And one of our interviewees said, CRAN primarily has the academic user in mind who want timely access to current research. And this timely access reflects the contrast, let's say, to Eclipse, where you have releases once a year. So these people are doing research. They want to publish things and want to get them out there. It still gets through a review process, but it's much faster than yearly releases. Interestingly, and I don't have much time to talk about this, this is a value that's not communicated on their webpage. It's not transparent. And if you ask people, rapid access or quick releases is actually not showing up as one of the key values that the community as a whole shares. It's actually somewhere between Eclipse and Bioconductor that both have yearly releases. So I think that to the developers of the community, the idea is we want to be faster than the turnaround of those yearly releases, but to package maintainers, it's actually slower than what they may be seeing in NPM, where you can just upload things. You have to go through this review process. So there are certain values where at least we speculate that they're not communicated well, so people don't really see why the ecosystem is designed this way. So again, there are trade-offs and costs and benefits. So they have relatively short release cycles. They achieve compatibility. It's actually pretty good usually at that. But at the same time, you have this urgency and this burden to react to updates. So at any time, there could be a breaking change that if you depend on that package, you may need to coordinate, you may get interrupted. And this leads to other consequences where people aggressively reduce the number of dependencies that they want to depend. They rather copy and paste code from another package than being exposed to this change, is something that we heard over and over again. And this gatekeeping causes additional effort and causes friction in this community. So this is always a contested point. So again, I've shown you another example that's probably very different from what you know. And I think I can make this shorter on Node because I guess you know the community much better there than me, actually. But my first contact with Node was something like this, right? Last week's tutorial is out of date today. This is a couple of years ago that I heard this. I forgot who the source was. But then you also saw things like this, which I think is pretty insane or pretty unique, that people actually started documenting the APIs, at least of the Node APIs, with stability indicators. They have this entire, it got simpler these days, but this entire infrastructure about things we're experimenting still with this API. You can use it, but it might change, and at some point we mark it stable. So implicitly, you can see that there are values that people are really open to rapid change, and they are open to experiment with APIs to get things right. It's a much more innovative community in a sense. Other design decisions are really trying to lower the barrier to entry. It's really easy to publish your first package on NPM, right? A really low bar. Also, you hear this in interviews with Isaac. And the goal here is really to make it easy and fast for developers to publish and use packages. If you look at stability, Node is not in the top space, right? This is not the value that's most important in this community. But if you look at innovation, this is where Node is at the far end, where the community thinks innovation is a key or is a very important value for us, among other ones as well. In terms of cost, though, it's pretty much on the extreme where it's really easy to just break something and let other people deal with it. The main saving grace here is that in Node, you're not forced to update, right? So you can stick to an old version, which you can't really do in CRAN that much. So you kind of, and in Eclipse as well, you can't really stay behind and partially stay behind on some packages, which is easy here. So there's some technology behind this. And there are actually a bunch of practices around this. So this semantic versioning is broadly adopted as kind of signaling what's breaking and what's not breaking. This is something that doesn't make sense to people in CRAN and R. To them, version numbers are just increasing you don't try to communicate what's breaking or not. It doesn't matter. The newest version of all packages should be compatible. Node or NPM has this technology infrastructure to allow you to use multiple versions of the same package, which helps you to solve the diamond dependency problem, which is pretty unique and very hard to translate to other languages, which is a key feature helping here. And then there's a lot of grassroots tool building from the community that tries to build tooling to kind of cope with large amounts of changes. Things like Greenkeeper and a bunch of these security projects that kind of try to filter changes for you, which are important and which are not. So in terms of trade-offs, again, there are costs and benefits. It's certainly a much more open community. It's easier to get in. It's attractive to new developers, at least compared to others, but it's perceived somewhat as unstable and as having little quality control, right? There's a lot of junk on NPM, and the rapid changes out there require constant maintenance, right? So at least if you decide to keep up, and that's usually a good idea, I guess, if you decide to keep up, you have a lot of changes to deal with in dependencies, and there are often a large number of dependencies, and then the community tries to help with tooling and community efforts to deal with this. So from an outside perspective, I have the impression that the amount of change in Node and in this ecosystem is slowing down a little bit, potentially because there are more commercial users who want more stability, more users in general, maybe a larger community. So is Node actually getting more stable? And maybe more importantly, should it get more stable? And I think this is an interesting question for the community to ask, because stability can be a nice value, but it also has its cost. And we have seen the extreme in Eclipse. And this might be worth to think about. So what I tried to show here is that culture really matters for an ecosystem, right? There are trade-offs. I've shown you 3 very different examples with different cost allocations, different people who are favored in this ecosystem. We can speculate about the reasons if you're interested. And in the survey, you see a number of other things that might stand out in one or the other direction, just to mention a few. Rust really values openness and stability. That's explicitly communicated. Ruby and Lua value fun. Go has a pretty unique versioning strategy. Stackage and Hackage are interesting. People are really aware about the difference in values in those communities because they have split out of the same thing over a conflict on how to deal with compatibility. And Maven is interesting because there's not much of a community around. That's essentially just a tool, or it's by most people perceived as a tool for replicability. And you can explore our webpage to see others. So again, community, culture of an ecosystem really matters. The values, the practices matter. Everything is a trade-off, and it helps to know the design space. It helps to know what are the possibilities of how we can reduce the amount of changes, what are the different mechanisms of how we can make it easier for users to update, things like this, and understand the trade-offs behind them. And our hope is that in the long term, when we actually understand all those things, we're just in the beginning, unfortunately, but when we understand those things, that we can deliberately design communities, that we can think about, we want to achieve this goal, what are the practices, how can we encourage people to do this, and that we can also debug communities, that we can, if we see certain health issues, like people are running away, people find this all low quality, what can we do, what might be effective things to change that have worked in other communities. Most people don't know that many different communities, 1, 2, 3 maybe, and don't often think about the explicit differences. So we think it really helps to understand the space and to understand. As I mentioned a couple of times, there's much more data behind this. There are also academic papers behind this. And we've created a web page, breakingapis.org, where we just today released all the results of the survey. So a large number of plots where you can actually compare different ecosystems, also compare personal values against community values, things like this. So feel free to have a look at this, explore the data. And we're always looking for feedback, always looking to discuss things. If you have a specific insight, share this. We would be happy to interview people, also learn more about those things. And with this, I get to my last slide. Because in the title of the talk, I ask how to break an API. And now I can at least answer this for 3 ecosystems that I discussed. In Eclipse, you just don't. In CRAN, you reach out to affected developers and kind of negotiate and release simultaneously. And in Node, you increase the major version number and you move on. That's it. Thanks.